All right, now we're going to compare the proportions, the percentages of two populations. And when that happens, we're testing claim about proportions of two populations. When that happens, you're going to follow these steps. Okay, so here's an example of how I will use these steps. In a study of 150 randomly selected occupants in passenger cars and 200 selected occupants in pickup trucks, 86% in passenger cars and 74% of occupants in pickup trucks wear seatbelts. At alpha equal 0.10, can you reject the claim that the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks? So let's follow these steps, okay? So step number one, I'm going to verify that the samples are random. And when I started reading, yes, it says that the 150 randomly selected occupants from the passenger cars and 200 randomly selected occupants from the pickup trucks. So we already met that first condition. The second condition, that the samples are independent. Well, because we're not working with the same object. We're working with two different objects. In this case, they are vehicles. We're working with passenger cars and pickup trucks. They're not related to each other. So that's how I know they're independent. So we passed that first step. We did that first step. Here we go with the second step. We're going to find something called the weight estimate of P1 and P2. So basically I had to use this formula here. Okay, but to use this formula I need some information. Okay, so right now in this problem we working with passenger cars and we working with pickup trucks. Okay, and what do I know about each of these? Well, I know how the sample size of the passenger cars, and that was 150. So I'm going to call this N1 because I had two vehicles. So the sample size of my first vehicle, passenger, N1, is 150. Okay, and the sample size for the pickup trucks, N2, okay, is going to be 200. And that's one of the first things I know. What else do I know about the passenger cars? I know something called P hat, the percentage of this sample of the people who was wearing a seatbelt, and it's 0.86. See, 86% in passenger car. So 0.86. And I also know the P hat. Oh, by the way, this is P hat 1. And I also know the percentage of this sample of the 200, P hat 2, okay? And what percentage of these 200 was wearing a seatbelt? 74%. So this will be 0.74. Okay, so as you can see in the formula, I have N1 and N2. I have that information here. However, I do not know who is X1 and X2, and that I'm going to have to calculate myself using basic math. So we need to find out of these 150 passenger cars, how many of these 150 passenger cars was wearing a seatbelt. I know the percentage, but I do not know how many cars out of these 150. Basically, we're going to do a simple math step, okay? Math computation. And the way you figure that out is you're going to multiply 0.86, the percentage, by the total of passenger cars. And that will tell you how many of these 150 cars, how many were the people inside were wearing a seatbelt. And there it is. Let's do the same thing for the pickup trucks, in other words, X2. So out of these 200 pickup trucks, I want to know how many pickup trucks exactly the people inside was wearing a seatbelt. I'm going to do the same computation, same basic computation, 0.74 times 200. And you can see I got 148. So out of these 200 pickup trucks, 148 of them the people inside was wearing a seatbelt. Okay, so I need this information so I can plug in. So now we're gonna plug in. I'm doing step number 2 right now. Okay, all of this is information I need to extract from the word problem so I can do step 2. And who we gonna find in step 2? We're gonna find something called P bar, which is the same thing as the weight estimate of P1 and P2. So what I'm gonna do, I'm gonna plug in this formula. X1, 129, plus X2, 148. All of that, I'm gonna divide it by N1, 150, plus N2, 200. And then I'm gonna use my decimal calculator to make things easier. Let me call my calculator here. There it is. I'm gonna type this in here. So fraction 129 plus 148 over 150 plus 200. You can see here I got this decimal. Usually we round to 3 decimal places, so 0.791. Okay, 0.791. And that's my P bar. However, I also need to find Q bar. And how do we find Q bar? 1 minus P bar. And my P bar was 0.791. That's what we got right above. So subtract these two. 1 minus 0.791. I got 0.209. That's my Q bar. And I did step number 2. Okay. However, I'm supposed to do a checking here. Okay, before I proceed to the other steps. So let me keep my regular calculator. I'm going to do my first check. N1, 150, times P bar, 0.791. Did I get more than 5? Yes. So this one I pass. Now I need to do N1 times Q bar. So same thing again. N1, 150, times Q bar, 0.209. Did I get more than 5? Yes. Why more than 5? Because that's what it says right there. So I did N1 P bar, N1 Q bar. Now I'm going to do N2 with P bar. So how much is my N2? 200 multiplied by P bar, 0.791. Did I get more than 5? Yes. So let me put a check mark under here. Now I'm going to do N2 times Q bar. N2, 200 times Q bar, 0.209. Did I get more than 5? Yes. So I pass all my checkings here. Now I can do step 3. That's what we're going to do next. Okay. You cannot do the other step below until you do all those checkings. And all the answers should be 5 or more. Now we're going to go step 3. In step 3 is we're going to have to write the claim mathematically. And what was the claim? It's down here. See, I know because they gave me the hint. Claim, whatever comes after, is the claim that I need to underline. So what was the claim? That the proportion of occupants who wear seat belts is the same for passenger cars and pickup trucks. So let me underline that. The proportion is the same for passenger cars and pickup trucks. So how do I translate that? That the population proportion for the passenger cars, we call that P1, is the same, equal, as the proportion of the population of pickup trucks, that's P2. Those two are the same. And I'm going to put that, remember that I need to write the word claim in parentheses because that's my original claim. It came from here, from the word problem. Let me move this up a little bit because I'm going to need the space. Okay, every claim has a counterclaim. So what is the opposite of being equal? That P1 is not equal to P2. Okay, remember that the claims, you need to label it as HO and HA. The one with HO, the one with the equal sign is labeled HO. The one without the equal sign is labeled H1 or HA. And I did step number 3. Let's go step 4. What is step 4? I'm going to find the level of significance. You can see it right there. So alpha is 0.10. That's all what I had to do there. Step 5, I'm going to put it right here. I'm going to try to maximize my space. Step 5, I need to do the picture. This picture, the bell-shaped curve. So here it is. Here's my bell-shaped curve. I need to shade a tail, or one tail or two tails. Who decide that? H1. When you have the not equal, we shading two tails. That's what I'm doing right now. Okay, I'm shading both tails. Good. Now I'm going to go step 6. I'm going to find what is called the test statistic. And how do you find the test statistic? We're going to have to use this formula here. Okay. So Z equal. Okay. Then I have a fraction bar. Then I start with first parenthesis P hat 1. Oh, we did that already. It's 0.86. I'm going to type it instead of writing it. So 0.86 minus P hat 2. Okay, that's 0.74. Close the parenthesis. Minus P, and the second parenthesis says P1 minus P2. Now, from the claim, P1 is equal to P2. So if they are equal, when I do the subtraction, this is 0. Okay, and that's how I fill up the top. The bottom, I'm going to do the square root of, now I need to multiply P bar. And how much is my P bar? 0.791. Again, I'm going to type it instead of writing it. 0.791 times my Q bar. That's 0.209. And then whatever I get, I'm going to multiply that by, now I open a bigger parenthesis, 1 over N1, who's my N1? 150. Plus 1 over N2, and who's my N2? 200. And close the parenthesis, and all of this is inside the square root symbol. I suggest you do this in decimals. That's what I'm going to do right now. Let me move it here to the side. Let me clean this up. Okay, so I have a fraction on the top. I have a parenthesis, 0.86 minus 0.74. Close the parenthesis, minus 0. I wrote the top. Now I'm going to do the bottom. I have a square root inside. I have 0, let me put in parenthesis, 0.791. Close the parenthesis, open the new one. Oops, let me close that. The second parenthesis is 0.209. Close the parentheses, open another parenthesis, but inside that last parenthesis I have two fractions, 1 over 150 plus 1 over 200. Close the parentheses, you can see my z-score. Okay, usually 2 decimal places, so 2.73. Let me write it right here. 2.73. Remember that this number is the label my marks here. So this is 2.73. This mark on the right, the positive one, is on the right. The negative one is going to be the same number but negative for the left mark, so negative 2.73. And I did step number 6. Let's go to step 7. What is step 7? I'm going to find the p-value. How much is p? How? Well, look at the formula. It starts with z equal. So that means I'm going to use the normal calculator. This one. And because I'm working with two-tail, click the drop-down menu and you're going to choose the third option. And I need to type in the blue box my t, I'm sorry, not my t, my z, 2.73. Okay, and hit enter. Okay, now you don't see the shaded part. It's really tiny here, but it's shaded. The two tails here are shaded, and you can see my probability, 0.00. Usually we use 3 decimal places, so 0.006. So 0.006, and I did my step 7, the p-value. Step 8. Okay, that's when I'm going to make the decision. How? You're going to compare your p-value against your alpha. Oops, let me erase that. I didn't want to do it that way. Okay, so my alpha, all right? Who's my p-value? I'm gonna type it instead of writing it. 0.006. Who's my alpha? That was step number 4.10. Okay, 0.10. From left to right, is the p-value bigger or smaller than alpha? It's smaller. And by this chart here, the first option, when the p-value is smaller than alpha, what's going to be my decision? Reject HO. Okay, and I did step number 9. Now we're going to do step, I'm sorry, that was step 8. Now I'm going to do step 9. And what is step 9? The interpretation. How? Looking at this chart. Check first or choose first your decision. That was step 8. We decide to reject, so we're in the first row. Next, find out where you put, where is the original claim in step number 3. You can see the word claim is in HO. So I'm in this first column. And look, when I look for the intersection of the first row and first column, I have this here. And what does it say there? There's enough evidence to reject the claim. That's what I'm going to put here. Enough to reject the claim. Enough evidence to reject the claim. What claim? That the proportions of passengers using a seatbelt between passenger cars and pickup trucks are the same. All right. I hope that helps.